Dear friends, welcome to this channel. In this video, I will explain the questions in CUCET 2020 chemistry paper, the questions from 51 to 75. Let us take question number 51. The energy of an electron in a hydrogenic atom with nuclear charge varies as. Here, hydrogenic atom means hydrogen-like atom or single electron containing atom. In this case, what is the relation between energy and Z? This is the atomic number of atom. Here we know that En is directly proportional to minus Z square by N square. If we take Rn is directly proportional to N square by Z. So in case of energy, the energy is directly proportional to square of atomic number and indirectly proportional to square of principal quantum number, that is N. So what is the answer? For this, what is the answer? The En is directly proportional to Z square. This is the correct option. The eigenvalue of Hermitian operator must be. Okay, what is Hermitian operator? Suppose if you take an operator, okay, when you operate on a particular function, psi operator, Hermitian operator, let us take A operator and psi. A operator psi star should be equal to psi star operator A psi. Here the element, the volume element is d tau. Here so the volume element is d tau. And if you take limits minus infinity to plus infinity, minus infinity to plus infinity. If this relation is satisfied, then the operator can be called as Hermitian operator. Okay, Hermitian operator may be real or imaginary, but the eigenvalues which are resulted, suppose if you take this is a Hermitian operator, when you operate on a particular function phi, you will get some value, it's a constant value, and again you will get a wave function. This one may be imaginary or real, or it may contain both imaginary or real, but this value, this one should be real value. Since it's a physical quantity, it denotes a physical quantity. If you take eigenvalue, this one denotes physical quantity. It should be real value. So what is the eigenvalue of Hermitian operator? Here this is the eigenvalue of Hermitian operator. This should be always a real number. An electron is found in an orbital with one radial node and two angular nodes. Which orbital the electron is in? Here number of radial nodes. Number of radial nodes is equal to n minus L minus 1. This is the principal quantum number. This is the azimuthal quantum number. This is the relation. Number of radial nodes is equal to n minus L minus 1. And number of angular nodes, if you take angular nodes, it will be equal to azimuthal quantum number, that is L. Here, how many angular nodes are there? L is equal to 2. 2 angular nodes, L is equal to 2. We know the orbital. When L is equal to 2, what is the orbital? For L is equal to 0, s orbital, 1, p orbital, 2, it's a d orbital. So it should be d orbital since L is equal to 2. Then n minus L minus 1 is equal to 1. So here we know the values. n minus, what is the L value? L is equal to 2. 2 minus 1 is equal to 1. So n is equal to 1 plus 3 is equal to 4. So n is equal to 4. Then what is the orbital? The orbital should be 4d. Here 4 indicates the n value, and here d indicates L is equal to 2. L is equal to 2. So what is the answer here? D is the answer. It's a 4d orbital. The normalization constant n for the wave function psi x is equal to n e power of imx, where this x ranges from 0 to 2 pi. Okay, how can you calculate normalization n value? Okay, here this is the limit 0 to 2 pi, and you have to take psi star, and here what is the x dx should be equal to 1. This is the condition for normalization. Okay, what is the normalization condition? Psi star dx integral 0 to 2 pi, these are the limits, should be equal to 1. That implies here we know the value of psi. Psi is equal to n into e power of imx, and psi star, the conjugate value of psi, is equal to n into e power of minus imx. Okay, when you take psi star, I will become minus I. So if you take psi star, that implies 0 to 2 pi, these are the limits, psi star n into e power of imx into n into e power of minus imx should be equal to 1. Here n into n square, that implies n square, it's a constant, you can bring outside, and 0 to 2 pi, and the e power of imx into e power of minus imx. So we know the equation. Suppose if you take a power of m into a power of n is equal to a power of m plus n. So here these two are equal, e and e, this one is e. So what is the equation you will get? Is equal to 1. That implies n square 0 to 2 pi. This one will be equal to e power of imx plus of minus imx is equal to dx here. Here also dx, you have to write dx, and this one dx is equal to 1. Here imx minus imx, so there will be 0. So that implies n square 0 to 2 pi e power of 0 into dx is equal to 1. Then what is the value e power of 0? It will be 1. So n square integral 0 to 2 pi 1 into dx, it will be dx is equal to 1. We know the integral dx, it's a x, n square. So this is the x, and these are the limits 0 to 2 pi is equal to 1. Then n square is equal to n square. Okay, if you substitute limits, you will get 2 pi upper limit minus lower limit, 2 pi minus 0 is equal to 1. So 2 pi n square is equal to 1. N square is equal to 1 by 2 pi. So n is equal to 1 by root 2 pi. So what is the normalization constant here? Normalization constant is 1 by 2 pi. The correct answer is B. The well-behaved wave function from the following function is well-behaved wave function. In quantum mechanics, the function should be well-behaved. What is the meaning of well-behaved? The function should be single valued, and continuous. The function should be continuous, and the values of function should be finite. then the function will be well behaved. If you take tan x square, the value is not finite, and x square in this case also the value is not finite, it is not single valued, and exponential x square in this case also the value is not finite. Here exponential minus x square, it's a finite, single valued, continuous, and first derivative is also continuous, and the second derivative there is existence of second derivative also. So this one is well behaved wave function. This one we come across these functions in orbitals of hydrogen atom. Orbitals of hydrogen atom are expressed in terms of exponential minus x square terms. So it's a well behaved wave function. What is the correct option? D is the correct option. What are the conditions for well behaved wave function? It should be single valued, continuous, and finite. Following the equipartition principle of energy, the molar heat capacity at constant volume for CO2, SO2, and NO2 gas follows the trend. What is the trend? Here, equipartition principle. Okay. Suppose if you take a molecule containing n atoms, let us take n atoms, then the degrees of freedom will be 3n. In this, we have translational, rotational, and vibrational modes we have. If you take any molecule, it has three translational. It moves along the x-axis, y-axis, and z-axis. So if you take any molecule, the translation will be 3. Suppose if you take linear molecule, the rotational degrees of freedom will be 2 only. And how many vibrational modes will be there? It will be obviously total 3n. So you have to remove remaining 3n minus 5. You have to remove translational and rotational. This is for linear. This is for linear molecule. If you take non-linear, obviously 3 translational, rotational also 3. It can rotate along the 3 axes, x, y, z axis. So vibrational will be 3n minus 6. Here the contribution to the energy, if you take translational, it is 1 by 2 RT, rotational is 1 by 2 RT, and vibrational is RT. So if you take linear molecule, we know that here CO2 is a linear molecule, and SO2, NO2, these are non-linear molecules. Let us calculate translational, rotational, and vibrational modes number of. In case of CO2, it's a linear, so it will be 3, 2, and total 3n. 3n means 3 into 3. Total number of atoms are 3. 3 into 3, 9. 9 minus 5, it will be 4. And if you take SO2 and NO2, these are non-linear. In this case, you have 3, 3, and 9 minus 6, it will be 3. Then what is the total energy? According to equipartition principle, what is the total internal energy for CO2? It will be 3 into 1 by 2 RT, and 2 into 1 by 2 RT, and this one will be RT. So you have 3 by 2, 2 by 2, it will be 5 by 2, 5 by 2 plus 4, it will be 13 by 2 RT. So this one is 13 by 2 RT. In this case, you have 3 by 2 RT, and this one is 3 by 2 RT, and this one is 3 RT. So you have 6 RT. This one is 6.5 RT, this one is 6 RT. Okay, this is about internal energy. Then you have to calculate molar heat capacity. We know the relation. Okay, molar heat capacity at constant volume, Cv is equal to dou U by dou T at constant volume. Okay, then if you calculate Cv values, if you calculate Cv, You have to differentiate with temperature. So you will get 13 by 2 R. It will be 13 by 2 R. This one will be 6 R. Which one is greater? 13 by 2 R is greater than 6 by R. So CV of CO2 is greater than SO2 and NO2. And CV of SO2 and NO2 are equal. So which one is the correct? CO2 is greater than SO2 is equal to NO2. This is the correct option. C is the correct option. The number of degrees of freedom in the homogeneous liquid region of a two-component system with a eutectic point at 1 atmospheric pressure is 1 atmospheric pressure. Suppose if you take a two-component system and eutectic system, if you take, this is a two-component system, the diagram will be like this. In this case, you have homogeneous liquid. This is a region which indicates homogeneous region. Okay, this is a temperature. This is the composition of mixture, and this is the temperature. You have to find out the number of degrees of freedom at this region, in this liquid region. Okay, here you have to use actually the equation is Gibbs equation is F is equal to C minus P plus 2. This is a relation between degrees of freedom, number of components, and the number of phases. F is number of degrees of freedom, number of components, and the number of phases. But when one degree of freedom is fixed, here the pressure is fixed, 1 atmosphere. You have to use reduced phase rule equation. This is a phase rule equation, Gibbs phase rule equation. Here you have to use reduced phase rule equation, that is C minus P plus 1. There is a reduction of 1 degree of freedom due to fixing of pressure. So this equation you have to use. F dash is equal to C minus P plus 1. Here it's a two-component system. C is equal to 2. Homogeneous liquid. Homogeneous liquid means how many phases will be there? Only one phase. If you take any homogeneous liquid or solution, the number of phases will be 1. So P is equal to 1. So number of components 2, P1 plus 1 is equal to 1 plus 1. It will be equal to 2. So the number of degrees of freedom in the homogeneous liquid region of two-component system with a eutectic point at 1 atmospheric pressure is, it's a 2. So option is C. C is the correct option. The ionic strength of 0.1 molar aqueous solution of Fe2SO4 thrice is, okay, here what is electrolyte Fe2SO4 thrice? For this electrolyte, what is strength, ionic strength? This one dissociates into 2Fe3 plus and 3SO4 2 minus. What is the concentration of this electrolyte? Is a 0.1 molarity. Okay, when this one is completely dissociated into ions, then what is the concentration? 1 mole of Fe2SO4 thrice releases 2 moles of Fe3 plus, so it will be 0.2 molarity, and this one releases 3 moles of SO4 2 minus, so into 3 it will be 0.3 molarity. So the concentration of Fe3 plus 0.2, the concentration of SO4 2 minus is 0.3. Then what is ionic strength? Ionic strength I is equal to 1 by 2 sigma Mi Zi square. Okay, here two ions are there. Here Mi concentration of a particular ion and Zi is the charge on that ion. So it will be 1 by 2. Let us take first ion Fe3 plus, concentration is 0.2 into what is the Z value? It's a 3 plus 3 square. It will be 9. 3 square. You have to take Z square. And second one, SO4 2 minus, concentration is 0.3 and what is the charge? 2, it will be 2 square 4. So you will get 1 by 2, 0.2, it will be 1.8 and 1.2. So 1.8 plus 1.2, it's a 3, 3.0, so is equal to 1.5. Here there is no 1.5 option, so it's a wrong question, it's a bonus. What is the correct answer? It's a 1.5 molarity. Okay. The work done during the free expansion of 1 mole of an ideal gas at 27 degrees centigrade to thrice the original volume is. Okay, let us take work done, W is equal to minus P external into delta V. It's a free expansion. Here the condition is free expansion. Free expansion means the external pressure P external is equal to 0. So when P external is equal to 0, what is the work done? 0 into how much volume it changed. The total value will be 0. So delta V, it will be 0. Work done in any free expansion process is 0. Okay, what is the correct option? D is the correct option. The quantum mechanical particle of mass m free to rotate on the surface of a sphere. Okay, this one rotates on the surface of the sphere. This is a particle. This is a distance from the center. Sphere of a radius r is in the state with energy 10 h cross square, not h square. It should be 10 h cross square by mr square. This is the energy. This is the energy which is given. Let us take easy. This is the energy. The degenerate of this is, if you take a particle which is rotating on the surface of a sphere, the energy is Ej is equal to h cross square by 2I j into j plus. It's a quantum number. J is a quantum number. The degeneracy will be 2j plus 1. These many states will be existed for value j. So here Ej is given. What is the Ej? 10 h square by mr square. Okay, you can write h square by 2 into. Here, when a particle rotate on the surface of a sphere, I is equal to mr square. M is the mass of the particle, r is the radius of the sphere. So it will be mr square, h cross square by 2 mr square. This one is given. What is the value? 10 h cross square by mr square. This one is j into j plus 1. What is the j into j plus 1 value? That implies j into j plus 1 is equal to, here there is a cancellation of h cross square 10, mr square 10, so it will be equal to 20. When j into j plus 1 is equal to 20, it will be j is equal to 4. When put j is equal to 4, it will be 4 into 4 plus 1. It means 4 into 5, so 20. So when j is equal to 4, the equation will be satisfied. So you can take j is equal to 4. Then what is the degeneracy? How many states, degenerate states are existing for j is equal to 4? It will be 2j plus 1. So 2 into 4 plus 1, it will be 9. How many states will be existed? 9 degenerate states. The coordination number of Cs plus and Cl minus in the cesium chloride structure respectively are. We know that cesium chloride, it's a body-centered cubic. In body-centered cubic, this one is very simple question. In body-centered cubic, this is a simple cubic. Here you can find cesium plus, and at each corner you have Cl minus. How many corners we have? We have 8 corners. These are Cl minus, Cl minus, Cl minus, Cl minus, Cl minus and Cl minus. The cesium has the close coordination with 8 Cl minus. So what is the coordination number of cesium plus? It's a 8. Since the formula is CSCl, obviously Cl minus has the coordination number of 8. Cl minus will be surrounded by the 8 cesium plus when you take complete lattice structure. So what is the answer? 8 and 8. So D is the correct option. pH of 10 to the power of minus molar HCl solution is close to. Okay, generally we use pH is equal to minus log concentration of H plus. Okay, but here what is the concentration of H plus? Here you will get H plus from HCl solution. Obviously H plus concentration of H plus from HCl, what is the concentration? It will be 10 to the power of minus 8 molarity. And also here the concentration of H plus from HCl is very less, 10 times less when compared with H plus from water dissociation. So you know the value 10 to the power of minus 7 molarity. In this case you have to consider the concentration of H plus from H2O. So what is the total concentration? The total concentration H plus total, it is from HCl and also H2O. It will be 10 to the power of minus 7, 10 to the power of minus 8. You can common it 10 to the power of minus 7, minus 8 if you common it, and it will be, let us take 10 to the power of minus 7. Okay. Then what is the value you will get? It will be 1 and this one will be 0.1. So it will be 10 to the power of minus 7 into 1.1. So what is the pH? pH is equal to minus log 10 to the power of minus 7 into 1.1 into 1.1. This is the equation. Then you can write minus log AB can be written as log A plus log B, log A plus log B. So it can be written as minus log 10 to the power of minus 7 plus log 1.1. So finally this one is equal to log 10 to the power of minus 7 means it's a minus 7, minus of minus plus, so 7 minus log 1.1. You will get when you substitute log 1.1 value, you will get around 6.96 like that. So this, what is the correct option? 6.9 is the correct option. C is the correct option. The indicator methyl orange is most suitable for the accurate determination of the endpoint of acid-base titration in the range. We know that methyl orange is a weak base and it is used as an indicator. Okay, this one is not suitable for the titration between strong acid and weak base. What is the range here? The indicator range is 3.1 to 4.4. This is the correct option. Okay. A crystal with A is equal to B not is equal to C and alpha is equal to beta is equal to gamma is equal to 90. What is the system? It's a tetragonal. We know tetragonal. For tetragonal, A is equal to B not is equal to C, alpha, beta, gamma is equal to 90. Trigonal, it's A is equal to B is equal to C, all are equal, alpha, beta, gamma equal, but not is equal to 90. This is a trigonal. We know for orthorhombic, A not is equal to B, not is equal to C. If you take matchbox is orthorhombic. In this case, alpha, beta, gamma is equal to 90 degrees. This is orthorhombic. If you take monoclinic A is equal to B not is equal to C. So what is the correct option? Tetragonal is the correct option. A is equal to B not is equal to C, and in this case alpha is equal to beta, and which is not is equal to gamma, not is equal to gamma in the case of monoclinic. So what is the correct option? Tetragonal is the correct option. A is the correct option. The atomic packing fraction of body center cubic basis structure is, suppose if you take a simple cubic SC and BCC and FCC, we have FCC, SCP and CCP. These are closed packing structures. In this case, what is the atomic packing fraction? Packing PF packing fraction. If you take a simple cubic, the packing fraction is very less. It is 0.52. Nearly half of the unit cell is occupied by the atoms. If you take BCC, it will be 0.68, FCC 0.72. So what is the correct option for BCC? Atomic packing fraction is 0.68. This is the correct option. For FCC, it's 0.74. So B is the correct option. The adsorption of hydrogen on tungsten is described by Langmuir isotherm with K is equal to 0.40 K Pascal minus 1. The fractional surface coverage at a pressure P is equal to 1 kilopascal is close to. Okay, here we know that theta is equal to Kp by 1 plus Kp. This is a relation. Here, adsorption hydrogen, Langmuir isotherm with K is given. K is equal to 0.40 kilopascal in inverse, and P is given. P is equal to 1 kilopascal. You have to simply substitute. It will be 0.40 into 1 plus 1 plus 0.40. So it will be 0.40 by 1.40. So what is the value you will get? When you divide with 14. So you will get 2. So around you will get 0.29, like that you will get. So what is the value? The value is 0.29. If you calculate 0.40 by 1.40, you will get 0.29. The turnover number for enzyme catalytic reaction is where E0 and R maximum are initial concentration of enzyme and maximum rate respectively are. What is the turnover number? What is the turnover number or turnover frequency? Okay, turnover number means a number of reactants converted into reactants participated, that is divided by, and the concentration of enzyme. Okay, what is the turnover number or turnover frequency? Then the number of molecules which are participated in the reaction per unit enzyme molecule. Per unit enzyme molecule, how many number of reactants are participated? Or for unit site, active site, how many number of reactant molecules are participated? Okay, this term is measured in terms of R maximum, and this term, the number of active sites is measured in terms of concentration, initial concentration of the enzyme. So it's a E0. So what is the correct relation? It will be R maximum by E naught. D is the correct option. A cyclic heat engine operates between a source temperature of 927 degrees centigrade, a sink temperature of 27 degrees centigrade. What will be the maximum efficiency? Maximum efficiency of heat engine. Maximum efficiency you will get in Carnot engine. So we know the efficiency of Carnot engine is TH minus TL by TH. So this is the temperature of temperature of the source. This is the temperature of the sink. This is the temperature of the source. Here high temperature, low temperature you have to take. The value should be in Kelvin here. You have to remember the value should be in Kelvin, not degree centigrade. Here high temperature TH is 927 degrees centigrade. You have to add 273. So what is the value you will get? It will be 1200 Kelvin. And TL is equal to 27 plus 273. It will be 300 Kelvin. So TH minus TL, it will be 900. TH minus 1200 minus 300, it will be 900 by, it's a 1200. And percentage you have to multiply with 100. If it is fraction, without 100. If it is percentage, you have to multiply with 100. So it's a 3 by 4 percentage 100. So obviously 3 by 4 it will give 75 percentage. The maximum efficiency is 75 percentage. The correct order of entropy of various states of CO2 is. We know that entropy, it measures disorder. As the disorder increases, entropy S increases. We know that from solid to liquid to gas, there is a increase in disorder. So there is a disorder. If you take disorder, there is a increase from solid to liquid to gas. So obviously entropy increases from solid to liquid to gas. Which one should have more entropy, more randomness? Gas, next liquid, next solid. So what is the answer? CO2 gas greater than CO2 liquid greater than CO2 solid. So C is the correct option. The number of degrees of freedom of liquid water in equilibrium with ice is. Here there is a equilibrium between water, liquid water and ice. So we know that if you take water system, for water system number of components is 1. In this equilibrium you have number of phases 2. So you have to calculate F value. So according to phase rule equation, F is equal to C minus P plus 2. It will be C1 minus 2 plus 2. So the number of degrees of freedom on curves. Suppose if you take water system, the phase diagram will be like this. Okay, on curves F is equal to 1. Regions F is equal to 2. And this point, triple point F is equal to 0. It's invariant. So the number of degrees of freedom on curve, that is equilibrium with liquid water, equilibrium with ice. What is the answer? It is F is equal to 1. A is the correct option. For a particle in a box, the total number of quantum numbers needed to specify its state. Particle in a box, if you take, it's a cubic box. In cubic, we have X, Y, and also Z. Okay, it depends on 3 quantum numbers, Nx, Ny, and Nz. So how many are required? 3 quantum numbers are required to specify this state. So what is the answer? 3 is the answer. The conductance at infinity dilution follows the order. We know that conductance, if you take conductance of an electrolyte or ion, is directly proportional to number of ions, concentration of ions, and the second one is directly proportional to indirectly proportional to size of ions. Lesser the size, more the conductance. Okay, as the size decreases, the fastness, the movement of particle increases. So there is an increase in conductance. Okay, in the case of lithium, sodium, potassium. Okay, if you take it in aqueous phase, as the size decreases, as a lithium has less size, and sodium has a little bit larger size, and potassium has a little bit larger. Okay, when you take in absence of aqueous medium, but in presence of aqueous medium, there is a hydration. Okay, when the size of ion is small, there is a more hydration. After hydration, the size of lithium increases due to hydration. This is the size due to hydration with water molecule. Then if you take sodium, this is the size. If you take sodium, this is the size, and potassium, this is the size. Okay, you have to consider the size of ion after hydration. Since lithium plus is smaller in size, it has more hydration power when compared with sodium and potassium. So the hydration size, radius, if you take for lithium plus, it is more. So it is very difficult to move lithium plus ions. That's why there is a decrease in conductance. So what is the order? K plus greater than Na plus greater than lithium plus. The mobility here, conductance depends on mobility. More the mobility of ions, more the conductance. As the size increases, the mobility decreases. Okay. So this is the correct option. Potassium greater than sodium greater than lithium plus. D is the correct option. According to the kinetic theory of gases, the ratio of the root mean square velocity of molecular oxygen and molecular hydrogen at 300 Kelvin is. Okay, root mean square velocity take. Suppose if you take root mean square velocity V RMS. Okay, this one is directly proportional to root T by M. If you take any velocity, it is directly proportional to root over temperature and indirectly proportional to root over mass. So here V1 by V2 is equal to root over T1 by T2 into M2 by M1. Okay, in this case, oxygen, the ratio of the root mean square velocity of molecular oxygen O2, first one is O2, and hydrogen, molecular hydrogen H2. Let us take. Here, temperature is same at 300 Kelvin, so the equation will become, there is a cancellation of temperature, it will become root over M2 by M1. What is the mass of 1 mole of O2 gas? If you take, it will be 32. If you take hydrogen, it will be 2. So obviously it is 32 by 32. Second one is hydrogen. So 1 by root 16. So it will be 1 by 4. So what is the ratio? 1:4. 1:4 is the ratio of the root mean square velocities of oxygen and hydrogen. The harmonic vibrational frequency for a diatomic molecule is μ1. If we increase the reduced mass by 4 times, what will be the resulting frequency? We know that mu is equal to 1 by 2 pi root k by mu. This is the reduced mass. This is the force constant. So if you relate frequency and reduced mass, then force constant is constant, mu1 by mu2 is equal to root mu2 by mu1. Okay, let us take mu1 as mu, and mu2 will be 10 times. If we increase the reduced mass by 4 times, okay, mu2 is 4 mu. And what is the relation? 4 mu by 1 mu root. So what will be the resulting frequency? It will be cancellation. So 2, what is a root? There is a cancellation of mu terms. You will get root 4. Root 4 is equal to q. So what is a mu2? Mu2 is equal to mu 1 by 2. So what will be the resulting frequency? It will be mu 1 by 2. B is a correct option. In a saturate calomel electrode, the saturation is with respect to, okay, this is in saturate calomel electrode you find, KCl and mercurous salt, that is Hg2Cl2. This is the correct option. In coming video, I will discuss remaining 25 questions in this question paper. Thank you.